Hey guys, I wanted to put out a video that shows a different method to find the LCM. This is going to be better for when there are three different monomials. I noticed a lot of y'all were getting like number 14 wrong on the assignment, so I wanted to post this for you. So I've done the upside down division method on the right over here, and you can see like I took out 3x that they had in common. And then what's left over, the 20y, 5x, and 3y to the fourth, they don't all three have something in common. So it's easy to fall into the trap of just saying, multiply all those together, and you get 900 x squared y to the fifth as the LCM. And that's wrong. It's not completely wrong. It is a common denominator, but it is not the least common denominator. So if you took the L off and just called it a CM, then you would be correct. But it's not the LCM. And we try to strive for the LCM because that's going to make our problems easier. Smaller numbers are easier to work with than bigger numbers. So here's another method. You come over here, and we're just going to write out the factorization of all of these. So like the numbers, we're going to break them down using a factored tree. So 60 breaks into 6 and 10, 6 breaks into 2 and 3, 10 breaks into 2 and 5. So there are 2 2s, a 3, and a 5. Let me put some multiply symbols. Then we're going to write out our variables as well. All right, we're going to do the same thing with the other two. So 15 is 3 times 5, and then we're going to write our x squared in expanded form. And then 9x y to the fourth. 9 is 3 times 3. Then we have an x, and then we have 4 y's. All right, and then the LCM is the smallest number that all three of these can divide into evenly. So it's going to be a bigger value than all three of these combined. All right, so the way you find an LCM is you want to pick out which one has the most of each individual item. All right, so I see 2's here. Which one has the most amount of 2's? Well, the first one does. There are 2 2's there. So our LCM is going to have 2 times 2 in it. All right, then I say which one has the most 3's. All right, this one has 1 3. This one has 1 3. The bottom one has 2 3's. So 2 3's are going to go into our LCM because that one had the most. Which one has the most 5's? Well, these two have the same amount of 5's, so you just pick one. It doesn't matter, but just a single 5 is going to go into our LCM. You're not going to put it in there twice. All right, you're just picking out which one has the most. If two of them have the same amount, then you just choose whichever one you want. All right, which one has the most x's? These two only have 1 x. This middle one has 2 x's. So we're going to have 2 x's in there. And finally, which one has the most y's? Well, the top one only has 1, the middle one has none, and the bottom one has 4. So the 4 y's are going to go in there. All right, and then you just multiply this all together, and that is your LCM. So let's see, we get, this is 4, this is 9, and then, so 4 times 9 is 36, 36 times 5 is 150 plus 30 is 180. Then we have x times x, which is x squared, and we have y times y times y times y, which is y to the fourth power. Okay, and so you can see that this is a much smaller value than 900, the 180. The x squared they had in common, so the x's were fine with the other method, but the y to the fourth power instead of the y to the fifth power. All right, and so using this method is a surefire way to get you to the LCM. The upside down division method works really good if you only have 2 monomials, but if you have more than 2, 3 or 4, this method is going to work a little better for you on those. So go back and look at like 13 and 14 that had the 3 monomials and see if you got the right answer already. Great if you did, but if you didn't, maybe go back and rework those using this other method and resubmit that for me. Thanks.